Hey guys, Kyle here, classicrooterspares.com. Thanks for tuning in today. Today we're going to be working on a set of Matchless G12 cases on the timing side. And the job that my dad wants me to do today is install and machine an O-ring groove. From what I've been told and what I've been explained to, the O-ring is supposed to help prevent any type of oil leaks that could happen when the oil pressure is great, typically when the motorcycle is cold. The gasket sealer between the two crankcase halves is simply not enough. Alright, now that we have the job explained, let's move forward and get everything ready. Alright, so the tool that I'll be using today is a Micro 100. This is a solid carbide boring bar, but essentially it is a grooving tool. So the radius is 1/16 of an inch, which happens to be same as the O-ring. So this is a great quality tool, and this is going to come in handy for this job. Alright, let's get the timing side crankcase set up. We are using 4 1-2-3 blocks underneath the case, and we're simply going to use a stud, washer, and nut to be able to hold the case down. Now on the other side, we're going to also retain that top portion to prevent the case from spinning. Making sure that the crankcase half is parallel to the table is not critical, but it's definitely enough on the 1-2-3 blocks, so we'll snug everything up. Now that the timing side crankcase is bolted to the table, there are a few dimensions that we need to note prior to working. I measured the diameter of the O-ring, which is 1/16 of an inch, and basically what I'm doing here is using a calculator for the percentage. My dad wanted 75% of the O-ring in the case, which means 25% of the O-ring will be sitting higher up. So that comes out to about 93 thousandths. To make life a little bit easier, we're going to grab our blue magic marker and we're going to color the circumference of the case. Now we need to be able to measure the existing hole in the case, and we're going to use our Starrett telescopic gauge, and we're going to use our caliper to measure the outside diameter. So the inside diameter of the case hole is 1.060, so we're just going to document that on the crankcase so we don't forget. So now that we have the dimension of the hole and the O-ring dimension, which is 1.25 inches, measuring the center line, we're going to use those two dimensions and then use our caliper to be able to scribe a line all the way around the existing hole. And the reason why we want to do that is because my boring bar doesn't have a micrometer and I can't measure it, so we're simply going to use a caliper to scribe the groove. And then in the later clips you'll be able to see that the groove is going to help us line up the boring bar so we can have the center line exactly what it should be when we're machining the O-ring groove. So as you can see, we have the O-ring groove that has been scribed all the way around. I use my caliper for this, and I'm sure now it makes sense that we use the blue magic marker to make it a little bit easier to see. So next thing that we're going to do is set up our dial indicator. We're going to use this indicator here to pick up the existing hole that we measured earlier. This is the hole that measures 1.060. So I'm sweeping the indicator all the way around. I'm moving the X and Y axis just to make sure that we can get it to 0. Now it doesn't have to be absolutely 0, but we have to get it as close as we possibly can. So this is the Micro 100 tool. And this is a tool that I made that's in a 3/4 collet. So this is simply a very simple tool that's going to sweep around to cut the O-ring groove. Headed over to the surface grinder, and we went ahead and removed material off the boring bar shank. And the reason why is because the 3/8 shank happened to be the same or parallel to the actual cutter. So using this tool, theoretically, I cannot cut a groove because the shank itself would be rubbing on the case. So I removed material, I guess you could call it an undercut, just to make sure that the shank was actually sitting lower than the cutter. The material is very hard on this Micro 100 boring bar, so it did take me some time trying to remove the material, and that's basically what the boring bar looked like after I was done. Really nice finish, it came out really great. Now that the boring bar has been cut, we are ready to start machining our O-ring groove. So I'm just going to touch off on the case, and then we're going to set our dimension to 93 thousandths deep. I'm taking it nice and easy to prevent any type of chatter considering the rake of the tool. So the RPM is about 60 revolutions per minute. Now that we've cut and machined the groove into the crankcase, we're going to grab our O-ring and we're going to press the O-ring into the groove. Now there's a few things that we need to check before we call this job complete. We need to check the depth of the groove and we need to check the O-ring protrusion. And from based off what I see and what I can feel, I think everything looks really nice and this job is complete. All right, so there you have it, another machine work job complete. If you enjoyed the video, don't forget to like and share the video, and don't forget to subscribe to our YouTube channel. For those that don't know, we do post a lot of videos and stories on our Instagram page, which happens to be @ClassicBritishSpares.